Okay, let's slowly start. So the small announcement is we again have a small change in schedule. Instead of Nikhil, we're going to be having Haidar. He's from Kaspersky, and I have a small story about it. We just actually met last week during the Black Hat, and I was like listening for his talk on the Black Hat, and I like approached him without telling who I am. I was like, I was like, why do I have to listen to your talk if I'm going to listen to that one in Kuala Lumpur?
Yeah, and I get surprised. Like, I didn't know him, like, and met him before, so.
Yeah, welcome to the stage.
Okay, thank you, man.
Good luck.
Thank you. Okay, thank you. So, hello, guys. I think it's hard, like, to get technical presentation after lunch. For me, I didn't expect that. Like, I ate too much because I supposed, like, to be the last talk. So let's have some fun. Who's here like have seen Mona Lisa in Louvre before? Anyone? No? I think it's worth it. Like it's under expectations. It's really small, but I think it's worth it. So you will see a lot of photos of Mona Lisa today in the presentation. So why Mona Lisa? Actually, the research depends mainly on exception that exist in every Windows machine right now. You look at it, it's like handled well by Microsoft. In another hand, like Mona Lisa also is just usual portrait for a woman. However, what is in common between Mona Lisa and the exception, that further you look, more you find. So, before we continue our story, a little bit about me. You can check all the information in this QR code about my work, but in short, I'm a member of Industrial Security Service team in Kaspersky, headquartered in Moscow. I mainly do Windows researching, and in our team, we analyze systems. So we should have many skills, starting from penetration testing to ICS, radio, application security. And in my free times, I chase bears in Russian mountains. I really like hiking, and I do some boxing, but fortunately, like not with bears. So let's have a closer look at Mona Lisa. A year ago, I was doing very complicated debugging in one of Windows services. And I had like multiple breakpoints, and I was reaching my first breakpoint by executing some command in the terminal. However, each time before I reach my first breakpoint, there is a thread that throws this exception. And it just made my life like miserable. I couldn't continue my debugging. I tried too much to solve this problem, but I couldn't. So I decided just like I want to go further and look to this exception in order to solve it. Like even if I had to patch this DLL, I will do it. But I didn't expect what I'm gonna find. However, before we see this exception in details, we should know about two of Windows technologies. The first one is called RPC, which stands for Remote Procedure Calls. And it's kind of inter-process communication mechanism when two processes want to communicate with each other. So they use something we call RPC. So, for example, like you have a host, which has two processes, process A and process B. And let's assume process B wants to execute some function in process A. So, So Microsoft takes this RPC and made it MSRPC, which will act as architecture for this communication. MSRPC work and client-server model. So the process A will expose an RPC server, process B will expose an RPC client, and the RPC server will expose its functionality, or let's see, the process itself will expose its functionality through something we call interface that implement functions. In our case, we have two functions, fun1 and fun2. And for each interface, we have a unique number. It's called UUID, just a GUID, to distinguish this interface between other interfaces in the same process or even in the system. So now we said like process B want to execute some function, and basically the client who will execute this function. So this client needs some point in order to connect to send some request to execute this function. And we call this point an endpoint. And we have multiple types of endpoints depending on the transport protocol used for communication between the client and the server. So if they use TCP, the endpoint will be basically the TCP port. If they use SMB, it will be NAND pipes. And today we'll concentrate on special type of endpoints. It's called ALPC ports. So what is ALPC is also kind of mechanism for inter-process communication used by Windows kernel. It's complicated. But for just simplicity, let's imagine the ALPC port as a file, just usual Windows file, where these two processes can write to and read from. And in our case, this port is called endpoint A. So now after the client wants to execute the function, it should send some request over this transport layer. So the request will contain the interface UUID that the client interested in. It will contain the endpoint that want to connect, and it will contain the function number. In RPC, we don't send names inside the request. We send numbers of the functions, which we called opnum. And for example, the fun one will have the opnum 0, the fun 2 will have opnum 1. And also, if there is some other security attributes in the request, it can be sent as well. So, hope it was not complicated. The second technology we need to know about is impersonation. So, what is impersonation? Assume you have a service that want to access some file that belong to different user. So, the service will take the identity of this user or impersonate this user, access these files and return to its original state. So this is in general what is impersonation. Today we'll concentrate on impersonation in RPC. So instead of telling like service, user, we will tell about server and the client when the server wants to impersonate the client and take its identity. And that can be done by an API called RPC Impersonate Client API. Now imagine if the client doesn't allow the server to impersonate it. So Microsoft came with a features called security quality of service, which represented by a struct with the same name. Inside this struct, we have multiple members. The most important one of us is impersonation level, which defined four levels that determine how much the client will give the server access to impersonate it. So if it set it as anonymous, meaning the server cannot impersonate the client, if it's identification, the server can do some basic stuff like checking the identity of the client. Impersonation is really high level and the server can do almost everything, except some network authentication. And delegation is the highest level in the impersonation. Now, also another problem. Imagine every RPC server can impersonate every client. So it will be a problem. Microsoft solved it by a privilege that should be enabled inside the token in the process that hosts the server. It's called SE impersonate privilege. And such example of such processes that have this privilege is the processes that run under service and local network and local service accounts. So I know it's a little bit complicated, but it will be more clear later. So the service that I was debugging, it was GPSVC. And what it is, it's a group policy service, which, as its name, it's used for applying and enforcing group policy settings in the system. If we have a closer look at it, it runs under SVC host, and it runs as a system. And I told you that I was getting this exception from executing a command. And the command was GPU update, or GP update, /force. I think most of you know about it, like you set some group policy in the settings and you want to apply it immediately, so you just use this command. So, the exception itself. The exception was RPC server unavailable, meaning the client couldn't reach the server for some reason. And this exception was raised by RPC runtime, which is RPC RT4.dll, and specifically by an API called NT-ALPC connect port. It's undocumented. And remember when I told you about this ALPC port that imagine it as a file. So the client will use this API to connect or open handle to this file. It has multiple arguments. We'll concentrate on 3 of them. The first one is the port name, which is just the file name, just a string. The second one is the require server SID, which will represent the identity of the target server that this port belongs to. And we have port attribute struct, which is basically has inside it security quality of service struct that we talked about before. And inside it, there is the impersonation level. Sorry. Inside it, you see the impersonation level where the client can determine how much control will give to the server in case of impersonation. Now, if we look at this like API during the runtime, when I had the exception, the port name was RPC control term serve API. Actually, RPC control, you can see it inside when you have ALPC ports in the local system, all of it starts with RPC control. The unique thing is like term serve API. And from its name, it belongs to term service. And what is term service is just remote desktop service, as all of us know about it. And this service is by default turned off. Like when you install your Windows, it's turned off. However, when you go to the settings and enable this service, the term service will expose an RPC server with multiple interfaces and endpoints. And of course, it runs under anti-authority network service. So, at this moment, I think it's clear why I get this exception. Like, basically, the group policy was trying to connect to the RDP using RPC, but for some reason, because it's turned off, I had this exception. So the solution was really easy. I will just enable RDP, and I will get rid of this exception. And actually, it works. Like, I continued debugging. However, after 1 hour, idea came to my mind. What if I mimic the server? What's that meaning? What if I have like access to another process, low privilege process, and I expose exactly the same RPC server exposed by RDP, using the same endpoint, using the same interface? The first question was, can I do it? The second one, can I do it? It's about like, can Windows allow me to do it? The second one, if I was successfully deploying the server, what I can do? And to answer these questions, we should follow the exception more. If we check the required server SID inside the API that's used by the client, it's actually, it's basically a pointer to SID struct. And if we get the value, it mapped to network service, which makes sense because RDP runs as a network service, right? And if we check the impersonation level, the client gives the server really high level. It's impersonation. So basically, the server can do everything like in behalf of the client, but there are some exceptions. Now, let's put it all together. You have a host, and inside it, there is a term service or like RDP service that runs as a network service, which has like SE% privilege, so it can impersonate clients. And it has an RPC server with interface and multiple functions and endpoint that we found. In another hand, we have a group policy service that runs as a system. It has a RPC client that try to connect to this RPC server. And I went deeper here and I checked the RPC request, and seems the client wants this specific UID with this endpoint, and it called like proc8, as we see with high impersonation level, and the target server identity is network service. So, to our first case of privilege escalation, I called it coercing group policy service. So, let's assume this scenario. You have exploit a low privilege service, like network service. Let's assume IIS that run as a network service. You will have SE% privilege by default. From there, you went and you deploy the exact RPC server exposed by RDP with the same interface, with the same endpoint term serve API. And in another hand, you came and you trigger the exception. And what's the exception do here? It just make the group policy that run as a system to make an RPC call with high impersonation level to your server. And from there, you can escalate, or you can impersonate the client and you can escalate to the system. At that time, this was totally theory for two reasons. The first one, I am IIS, not RDP, right? Will Windows allow me to deploy the same server that exposed the same endpoint? This was the first question. The second one, even if I deployed it, maybe there is some check inside RPC runtime that will prevent this group policies that run as a system to connect to me. And I had these two questions. The best way to answer it by try the exploit, right? So to the left, you have like Windows Server with this specific 2022 with this specific IP. And to the right, we have a web shell on the IIS. Just like imagine you exploit some web application. You can execute commands and you can upload files. If we check who am I, it runs as a network service. Now here I run Process Explorer to show you the exploit. Server.exe, I called it. It's just the RDP, RPC server. I upload the server. And I run it. In another tab, here like I check the identity of the server. It was network service, nothing special, right? Now in another tab, I trigger the exception. I make group policies that run as a system connect to my server. And I get CMD. If we check the privilege here, I'm a system, and here the most powerful calculator. So, seems it works, right? However, there is one condition for this exploit to work. One group policy should be changed at least on the system. Anyway, like at that time I thought, okay, like Microsoft has some bug in this specific service that allow me to escalate my privilege. So, but there was a question. What if there's another services try to connect to the RDP that is turned off as well? So to know the answer, I just made this exploit run as a network service that starts after the reboot immediately. And let's check how many CMDs will be spawned. Or in other words, how many services will call my server. You see how many of them, and all of them is a system. And like each 5 seconds, I had like a new CMD. So what I figured out, like inside our host, we have this RDP service that exposes this RPC server, these functions and endpoint. And on the other hand, we have multiple Windows services that try to connect to this service. And actually what's happening under the hood, that we have a DLL called winsta.dll. All the calls came from this DLL. And what's happening is that each service of these services, or the process itself, calls some API. This API implemented inside DLL, so it will be mapped to this service process address. And under the hood, this DLL will use RPC to communicate with the RDP, which is actually not a new behavior. Like Windows depends too much on RPC. So like you call some API, but this DLL meant to communicate with like another process, so it used under the hood RPC. However, what is the problem here? That it seems any service that run under the same, let's say, identity, a network service, can expose, and actually like here, not necessary to be identity, any service with any low privilege user can exactly expose the same RPC server that exposed by a legitimate service, regarding if it's the same service or not. And in another hand, RPC runtime will allow these services to connect to these fake RPC servers. So the question was like, why? I think it's the same like of this famous penguin, and as wise man said, once we will never know. Now, again the problem. You have like service turned off, and you have another low privilege process that can expose the same RPC server exposed by this service. And it can like get all the communications coming to this like RDP server. And the RPC runtime will allow this clients to communicate to your like server. Now, this is the problem here. It will be like architecture problem, because what will happen? Like you have an application that calls some API, and this API maybe under the hood will trigger some RPC code, and if the service is turned off, so these applications in your system will trigger local privilege escalation without like knowing if it's turned off or turned on. So actually at that time I could conclude the research because I knew the reason, I knew the bug, I had like working exploit, everything was good. But I kept looking at Mona Lisa and I felt like there is more. And how I can collect this more things is by gathering information. In other words, like I want to collect more exploit paths just to show it. And the best way to do that by collecting the exceptions. So to collect the exceptions, we should have two criteria actually. The first one related to the exception itself. So the exception should be RPC server unavailable, makes sense. And it should be originated from high privilege process because it makes sense to escalate our privilege to this process. And it should have used like high impersonation level. And the second criteria related to the monitoring framework that we will use to collect these exceptions. So this framework should allow you to extract all RPC metadata that you want in order to mimic the server, like UUID, endpoint, opnum. Also, it should allow you to filter for, or like it should show you the impersonation level, a status code, the process name, all of that you can use it for filtering and further operations. Now, this framework is called ETW that allow to do all of these things. ETW is also like very famous. It's event tracing for Windows, and it's used to capture kernel and user mode events at real time. And there is a tool called Logman, allow you to start this like tracing sessions, and you can select the provider, like which service you are targeting, RPC, like I don't know, HTTP, other services, and it will give you, the Logman will give you output as an ETL file that you can open inside Event Viewer in Windows and check these logs. And as expected, like ETW provide like very deep analysis of RPC, give you a lot of logs about RPC with a lot of information. And you can get all the information that you want. However, like it's, when you get your file, the ETL file, it's really big. And if you put it inside the ETL, it's really hard to view. So it's really hard to filter the exceptions that you want. So for this reason, I developed small scheme. So first you run the ETW, you have ETL trace, you convert it to JSON using like many tools online. And you have this JSON file and you give it to Python tool. What does this Python tool do? First, it will filter for RPC stop event, which is belong to event ID 1 inside the logs. And from there, you can get the status, the image name, process ID, and endpoint. And you can filter the exceptions for status RPC server unavailable. And after that, you match this event, like using the process ID and endpoint, you can match it to another event, which is belong to event ID 5, meaning the RPC call has started. And from there, you can get the UID, opnum, the impersonation that you want to, in order to complete your final entry. So you can make it together, and you have this JSON entry that all information that you need is there. However, it's as like, let's call it bonus, you can map the interface UID to some open source database for RPC interfaces. Like there is online, for example, from Akamai, there is an like database that tell you each system DLL, which RPC interfaces it exposed, and where it's located, what is the name of the DLLs that's implemented to, how many functions that it has. So from there you can get all this information, and in the end you have like very nice JSON output. For example, here is an example from like Windows machine. You have like WMI with this process ID. It's tried to connect to this endpoint, and it couldn't found it, of course, with this specific interface UID with impersonation level 3, which mapped to the impersonation. And it tried to call procnum number 9, and you can find the implementation of the server inside this DLL, term server DLL, which also helpful like if you want to reverse the server itself. Now, you saw before that I found this, like I found it I found this problem by accident. I was just doing GPU update force. So we need a way to generate these exceptions because it cannot be like by its own just be generated. So as a simple algorithm, we can reboot the system and start these sessions after the rebooting. As we saw, like the service will be started, APIs will be called, and like RPC will be triggered. Also, we can run some automated scripts that perform administration things, like I don't know, creating user, updating the group policy as I did before, and also RDP was turned off by default. But what if another administrator turned off another service? So we can turn off each service in the system and try to repeat the first two steps. So let's check now the results that I get. The case 2 is user interaction from Edge to RDP. So I think all of you know Edge. It's installed by default in all Windows. And for some reason, in some cases, when a user open Edge, it will make a call to RPC RDP server with high impersonation level. So how we can exploit that? The same situation, we have like the network service exploit, and we can deploy the same server. And from there, we will wait this time the administrator to just run the Edge. We will have a call, and we will escalate our privilege. The case 3, abusing background services. So it seems that there is some services that should run in background. It's like send some request from time to time to the RDP service using RPC. One of them is called WDI system host, and it's used for some diagnostic and troubleshooting tasks inside Windows. It runs as a system. However, it's like turned off, but there is another service trigger it always, so you always see it running. So this time it will be exactly the same, but we will wait from 5 to 10 minutes. This service will make call to our server and we escalate our privilege. The case 4, abusing local service account. So remember when I mentioned the client call, I said the client set some identity of the target server. It should be network under network service account. But what if we exploit a local service account? How we can escalate our privilege? So we have a service inside Windows, it's called DHCP client. It's different from the server, and it's responsible for DHCP client operations, like communicating with the DHCP server itself. And it runs as a local service, and it's running always. And it seems that it exposed an RPC service with multiple interfaces, and many system DLLs call this RPC server with high impersonation level. So the exploit this time, we will exploit a local service account, we'll deploy the DHCP client service RPC server, and we will wait user interaction. And it seems when the IP config has been like executed by the administrator, which makes sense, it will make call to this service and we can escalate this time to administrator. But the DHCP service should be turned off. I mean, basically, I think no one will turn it off, right? But here I just give you an example about how we can exploit the local service account. So we don't know. So our last actually example about privilege escalation is related to abusing time. So we have a service, it's called Windows Time Service. This service, from its name, it's used for time synchronization between in the network, and it runs as a local service, and it starts after reboot. And it exposes an RPC server with two endpoints. The first one is name pipe. We never met name pipe in this presentation, but just imagine it as also a file. So it exposed like 132 time underscore alt as an name pipe, and the same as an ALPC port. So we have a host, we have this service, and it seems we have an executable. It's called 132tm.exe. And basically, this executable used for time synchronization. So the administrator will use it in order to like sync the time and communicate with this service. So this executable, for some reason, it will connect first to some named pipe called when32 time. However, like the legitimate endpoint is when32 time underscore alt. And if this client couldn't find this when32 time, it will go to the alt. And I called this executable as, or like executables as a ghost lovers, because I don't know why, but for some reason, it will use this endpoint. And I assumed that maybe it was like in a previous Windows version, and now they use the new one and they forget to take it off. Maybe, we don't know the reason. So how our exploit will look like? We exploit the local service. We deploy malicious executable as an RPC server, but it will expose when32 time, not underscore alt. And we will wait the user interaction to, as an administrator, to run when32 time, and we receive it, and we escalate to administrator. But here, like, it's really important note that the time service not need to turn off, as I said, because we will expose this ghost lover endpoint, and it will connect to our server. So, I mean, I assumed that there is more executable have the same behavior. More ghost lovers also try to connect to some non-existent endpoint. However, I'm like in a process to collect these ghost lovers. I will share it when I will have it. Now, we are good people. We love community. So we created a report, 10 pages to Microsoft. And after 1 month, Microsoft returned with this answer. I will have a water and read it. So basically what they say, okay, there is a problem, but it's not critical. It's moderate, as they describe it. And what was the reason is that to successfully achieve this privilege escalation, you need SE impersonate privilege. And they take in account only the situations that I mentioned, that when you have SE impersonate privilege. But I believe, I'm not sure, but I believe even maybe some low privilege processes can exploit this bug and escalate the privilege. Now, how we can detect it? This type of activity cannot be prevented because you need a patch from Microsoft. The attack surface is really extensive, right? Because you don't know which services or which applications run in the system, which services is turned off, which services is turned on. You don't know. So the mitigation will depend on Microsoft how it will solve this flow. And but however, in situations that I mentioned that exploit the SE impersonate privilege, we can use the same techniques that used for potato exploit, because like Microsoft has a lot of problems using SE impersonate privilege. Also, as a solution, or not solution, as maybe detecting mechanism, inside this repo there is the tool that you can use for detecting the RPC server unavailable exceptions. So you can, maybe some users are interested on checking their systems if they have it. So maybe they can turn on the services, or like if they can to do that. So in conclusion, all the POCs is just simple examples. I believe maybe there is other cases that exist. All the POCs was discovered and tested prior to the report date of 29 of September 2025, and it was on Windows Server 2022 and Windows Server 2025. But anyway, I tried it every day and it still works. So in the end, thank you guys, and you can check our Purple Shift blog, like it's for our team, my Twitter. Thank you.
Thank you, Haidar.
We don't have time for questions, right?
Say it again?
Do we have time for questions or no?
I think we can take one question if we have.
Yeah, I mean, I will be available also here. You can ask me whatever you want. Any questions? I think.
Yeah,
no?
maybe even 2 questions. Yeah, we
Two?
have some time, yes.
Okay, so questions. I think there is no questions. Anyway, guys, like I will be available also. Ping me on Twitter. Ask whatever you want. Thank you. Thank you again.
Thank you.